I'm Tim. This PCB Sync.
The parameters of Rogers RO4003C and RO4350B look pretty similar, so how should you choose between them? In this video, we'll compare these two materials from several aspects: electrical and mechanical constants, loss, thermal performance, flammability rating, and their impact on actual design. Let's take a look at the datasheet first. Let's start with the important electrical section. The decay of RO4003 is 3.38 with a tolerance of plus or minus 0.05. RO4350B. Its decay is 3.48 with the same tolerance of plus or minus 0.05 for design and transmission in real-world applications. RO4300. And the electrical constants of RO4003C and RO4003B are different. One is 3.51, the other is 3.66. What about loss? Under the conditions of 10 GHz and 23 degrees Celsius, RO4003. Its typical dissipation factor is 0.0027. For RO4350B is 0.0037. So, according to the official typical parameters, the dielectric loss of RO43 is actually slightly lower, so you can't simply think of RO4350B as a more advanced or upgraded version with better performance. Now, let's take a look at the circuit. This is an open source distributed amplifier example operating at 5.8 GHz. The RF input is Z1 and the RF output is here. D3 is used for bias control. The section from TLE to TL4 in the middle is the transmission line structure. They work together with diodes and matching components to achieve different signal phases. In these high-frequency circuits, the traces themselves are part of the circuit. The width and length of the traces, as well as the board material, affect impedance and electric field strength. If you change the design from RO4003 to RO4350B because the decay values of the two materials are different. Even if the copper trace shapes are exactly the same, the impedance and phase may still change. So you can't just swap the material name between these two. The layout and stack up must be recalculated. Now, let's go back to the datasheet. Besides DK and DF, you also need to look at thermal properties and certification requirements. Let's take a look. The Z-axis coefficient of thermal expansion for RO4003C is 46 parts per million per degree Celsius. For RO4350B, it's 32. Both materials have a decomposition temperature above 280 degrees Celsius. The TG value for RO4003 is 425 degrees Celsius. The TG value for RO4350B is 390 degrees Celsius. As for thermal conductivity, RO4003C is 0.71 watts per meter Kelvin. RO4350B is 0.69 watts per meter Kelvin. The two are very close, almost the same. The real difference lies in the flammability rating. RO4003 does not have the UL94V0 rating. Here it's actually marked as NA. But RO4350B does have it. It is certified to the UL94V0 standard. If the product specification clearly requires V0, then RO4350B is usually the easier option for certification. As for processing, let me take another look. Both materials belong to the RO4000 series. Both can be processed using a method similar to standard epoxy glass fiber processes. So the main difference between them isn't that one is easy to process and the other is particularly difficult. The real selection logic is, if your project values a low-cost dielectric material more, and at the same time there is no V-0 requirement, you can prioritize evaluating RO4003. If the product must meet the V0 flammability rating, then it's more suitable to prioritize evaluating RO4350B. In addition, you also need to consider factors like operating frequency, type of copper foil on the board, impedance requirements, insertion loss, supply situation, and cost. Make a comprehensive judgment. Let's look at this again in the context of a circuit. Suppose the same 5.8 GHz RF design needs to use both RO4003C and RO4350B. At least 3 items need to be recertified. First, recalculate the impedance for the corresponding trace width. Second, recalculate the physical length of the transmission line based on the dielectric constant, dk. And third, combine the copper foil surface treatment and the processing factory to reevaluate insertion loss and phase error. Selecting high-frequency materials isn't just about comparing a single DF value. You need to truly consider the actual electrical performance requirements. You have to put all the guiding conditions together to make a judgment. If you're choosing between RO4003C and RO4350B, we can help you with material recommendations. You can also evaluate stack-up impedance calculations and DFM reviews and select them directly on the BCBC Core online quotation page. Just fill in the number of material layers and the quantity to quickly get a quote. The link is provided below the video. If you found this content helpful, please like and subscribe.